So here we go, quiz number 2. Got to have my favorite student, good old Anne. Object is pulled. Anytime I see this phrase, I mentally or actually underline it, because this tells me that the acceleration is 0. This tells me that forces are, I'm looking for a word that means letter B, balance. It tells me a lot of information. They want me to find the coefficient of friction. They want me to find mu. This is a job for a free body diagram. Now, how do I know that? There's definitely, Courtney, a force of friction in this question. And I have another force here. I have more than one force. I probably want to draw this out. Although since they gave me a picture, Ben, rather than do a separate free body diagram, I'm just going to label the picture. What are the forces acting on it? Get the obvious one. I have gravity down. Am I sinking into the ground like quicksand? Am I flying like Superman? Here, vertically, I have normal force up. I have F applied. This is the 12 right here. And I have friction right here. Now, normally, Blake, I would say, who's winning? Who's losing? And I would go, winner minus loser equals what? MA. But because it's at a constant speed, I think I can say that this force and this force are balanced or tied. So if I wanted to take a shortcut, I could go like this. F applied equals friction. Now, they want me to find mu, the coefficient of friction. So now I'm going to say friction is what times what? Friction is mu times the normal force. And F applied as a number is 12. How would I get the mu by itself? The coefficient of friction. How would I get that by itself? How will I move the normal force over? Divide what? I can't hear you, sorry. I think you're right. Okay, you divide the normal force over. So I'm going to get this. Mu equals 12 divided by the normal force, although I don't know the normal force. Oh, but look. I know another force the same size as the normal force, and so somewhere along the way, Logan, in my mind, I would replace the normal force with mg. So it's going to be 12 divided by 5 times 9.8. There's more than one thing in the bottom of this fraction, so I'm going to have to use brackets around the bottom. 12 divided by 5 times 9.8. And I get 0.2444, looks like A. Yes, is that right? Okay. Number 2, a free-falling object falling downwards and accelerating downwards experiences a force due to air resistance of 1.4 newtons. What's the object's acceleration? This is a job for a free body diagram. Again, how do I know that? They've given me a force of air resistance, and I know, get the obvious one, gravity. Is there more than one force in this question? I probably want to draw this one out. So I'm going to represent the mass with a dot. What are the forces acting on this? Get the obvious one. Yeah, go systematically. Don't rush to, I don't know what to, relax, go systematically, and usually you'll partway along the way, you'll have that, I can see where we're going moment. So mg. What else? The question mentions air resistance. Which way is air resistance going to be pointing? Depends which way this object is moving. If this object was moving up, which way would air resistance be pointing? And then my equation would be winner plus winner, no loser, equals ma. Here, it does say that we're falling or moving downwards, so air resistance is going to point up. Bigger, smaller, or the same size as mg? How do I know smaller? Not moving down, accelerating down, very different. Okay, we actually looked at a parachute situation where when I pulled my parachute, I was moving down but slowing down, which meant I was accelerating up and air resistance was bigger, which was a good thing. Otherwise, I wouldn't be here to talk to you. I mentioned I jumped out of an airplane. Otherwise, I wouldn't be here to talk about that. So we have to think this carefully. There's always a difference between which way are you moving and which way are you accelerating. But I agree with you, Rowan. Absolutely, it's going to be smaller. And so now, Rowan, who's winning? Winner minus loser equals MA. Once you get to this step, either, I like this question, well, it's not a quiz, so I do. Courtney, either I'll give you the acceleration and say find the air resistance, Or, in this case, I'm giving you the air resistance and saying find the acceleration. How would I get the A by itself? And this is also why I told you at the very beginning of this unit, don't try and memorize all these equations. It's going to be tougher. I'm going to teach you how to derive everything, Kenley, from scratch. And once you wrap your brain around it, it sure is much nicer than trying to memorize every single situation. But I know it's trickier to get there. Kenley, how would I get the A by itself? How to move the M over? And I'm lazy enough that on this line, I'll often go, ha, boom. And I'm fine if you do that. As long as you cross out the M to me, you have shown your work, and I'm okay with that. So I'm going to go to numbers now. M, 0.62, G, 9.8, minus 1.4. Do I need to multiply that by 9.8? No, they gave it to me in newtons. It's a force. Divided by 0.62. I have no idea what the answer here is. 0.62 times 9.8 minus 1.4 divided by 0.62. Oh, more than one thing on the top, so I put brackets around the top. Do you get 7.54? Oh, I knew it was going to be less than 9.8 because in a vacuum with no air resistance, it would be 9.8. And I kind of figured not much air resistance, so I figured it'd be close to 9.8. How many sig figs should I technically go to, by the way? 0.62. How many sig figs is that? Brushing the cobwebs off, I know. How many sig figs is 0.62? It's either 3 or 2. Good. Which one? 2. How many sig figs is 1.4? That's a little easier. 2. So how many sig figs should I probably technically go to? 2. So I'm going to go to 3 because I usually do anyways. 7.54 meters per second squared. If you got that right, 2 out of 2. Got a question? Oh, that was in the room there. Otherwise, I would give you 1 mark if I saw that equation, half mark for the numbers, and a half mark for the answer. As long as you can get the equation, you can pass the question. But I also absolutely recognize getting the equation is the tricky part. Is that okay, Riley? Yeah? Are you lying to me? Okay. Turn the page. Hey, Riley, what am I asking you to find in number 3? The what force? And I've told you what that means is I've done the winner minus loser, and you can go straight to F equals ma. Oh, this is easy. Did they give us the mass? What? 1,200 or 1,200. Did they give us the acceleration? Rest is an acceleration? By the way, welcome back. We had a little break there. When I say acceleration and I asked you that question, you should have looked for one of 2 things. What units should you have looked for? Who remembers? For acceleration? This is why I've told you it's worth memorizing units. I scanned it for meters per second squared. I didn't see that. Then I looked for steady speed because that would mean that the acceleration was what? Which would probably make this question pretty boring because it wouldn't be going anywhere. So I'm going to ask you again, did they give me the acceleration? So even though this question said find the net force, Riley, you know what I'm going to spend most of my time finding? Yeah. There's my high tech. A equals question mark. What's that from rest tell me? What starts at 0? Which physics concept? Don't use the word it. Okay, what's that 15? Yeah, what is it? Help them out, folks. We need, huh? Which one? So what's that rest tell me? Which one? Yeah, now you know where I'm going with this. Okay, and what's that 85? Good. You're back now, my friend? You looked like you were zoned out there. I apologize. Okay. All of us, we would go looking at our formula sheet. We're in that row of 4, I think, where's the VF equals VI plus AT and the D equals VI. We're good? Giggling? Did I say something funny? No. You're just laughing at me? No. Okay. I would be looking at my formula sheet, which I would probably have out. Mr. Dueck says hinting. Unless you still got these memorized. I think we're going to end up using the VF squared equals VI squared plus 2AD. I think we're going to get A equals VF squared minus VI squared all over 2D. It's going to be 15 squared minus 0 squared all over 2 times 85. 15 squared. Logan, if I type minus 0 squared, will that make a difference to my answer at all? What's 0 squared? What's 0 times 0 in your head? So will minusing 0 make a difference at all? Although I wrote the 0 squared, I'm not going to bother typing it in my calculator because I'm lazy. And I get 1.323. I'm going to write 1.32. But when I walk it over to here, I'm going to use my answer button. The net force is going to be 1,200 times 1.32. It's going to be 1,200 times, answer button. Do you get 1,588? I'm going to go 1,590 newtons. I'll go to 3 sig figs. Half mark off if you forgot the units. If you got that right, 3 out of 3. Otherwise, I would probably do something like this. I would give you a half mark if I saw F equals ma. I would give you a half mark if I saw that, and a half mark for the answer. I would give you a half mark if I saw Vf squared equals Vi squared plus 2AD. I would give you a half mark if I saw Vf squared minus Vi squared all over 2D, and I would give you a half mark for that. But if you got the right answer, 3 out of 3. 2 out of 2, Mr. Dueck. That was totally wrong. I thought this was a 3-mark question. Boy, that marking scheme is totally wrong. Let's change this then. Okay, I'll skip giving you a half mark for that, and I'll skip giving you a half mark for that. I don't know. That was dumb. Number 4. A block initially at rest is pulled by blah, blah. Ooh. Antonio, what's this question want me to find? Okay. Antonio, what's VI? What's that 16? What else do I need if I want to find V final? I can either go acceleration or time, but since I see forces, my mind would think, I'll bet you, even though this question wants me to find VF, I'm going to spend most of my time finding acceleration. You okay with that? And you know how I'm going to do that? This is a job for a free body diagram. How did I know that? I see an applied force. There's a coefficient of friction, so that means there's a force of friction. What are the forces acting on this? mg down, normal force. I have F applied is 56, and I have friction. I'm going to try and get the acceleration over here. Who's winning? F applied. Who's losing? Friction. What's that equal? ma. What do they want me to find? Vf. What do I need to find Vf? A. So I'll get the A by itself. It's going to be F applied minus friction is what times what? My brain would think mu times the normal force, but then my brain would say, I don't know the normal force. Oh, but look. I know another force that has to be the same size as a normal force. In this diagram, the normal force is mu mg. On your next quiz, which is going to be a couple of days from now, I'm going to have extra vertical forces in the diagrams, and so the normal force won't be mg. You'll have to do some thinking, and you'll have to generalize everything down equals everything up and figure out how big the normal force has to be, okay? Over m. A is going to be 56 minus 0.24 times 12 times 9.8 divided by 12. 50, brackets, Mr. Dueck. I got an acceleration of 2.31. I'm going to walk that up to here. I think I'm going to use Vf squared equals Vi squared plus 2AD, except Antonio, how would I get the Vf by itself? It's already by itself. Technically, no. How am I going to get the Vf by itself? Square root. So, oh, and you know what? Vi is 0, so I probably didn't even need to bother writing that one. Vf is going to be the square root of 2 times A times D. Although, Antonio, I'm going to use my answer button instead of typing 2.31. 2 times answer button times, what was D, 16? Square root of that. You'll get 8.61, 8.6. Meters per second. If you got that, I'm impressed. 3 out of 3. Otherwise, I would probably do something like this. I would give you a half mark if I saw that, a half mark if I saw that, and a half mark if I saw that. I would give you a half mark if I saw that. I would give you a half mark if I saw that. And I would give you a half mark for the acceleration. If you got the acceleration wrong, but you successfully did that, then you can get 1.5 out of 3 still. Mr. Dueck, yes, Savannah, who drew that wonderful artistic skier? Why, thank you. I drew that myself. Very proud. Oh, okay. Jackson, what's this question you want me to find? My first thought was, well, VF and VI, because we just found an acceleration using that, and then I went, I don't see a VF or a VI or a D anywhere. I think I'm going to find acceleration using forces. So you know what that means? This is a job for except did they give me a picture? I'm going to label this wonderfully artistic, incredibly accurate skiing picture. Yeah. What are the forces acting on the skier? Get the obvious one. We obviously have gravity down, normal force up, and I think they're the same size. There is a force forwards. I'm going to call it F applied because you actually, if you want to be technical, you push backwards with your poles, but there is a force for it's the snow pushing against your poles, pushing through your arms, pushing you forwards. Look, Ben, I do know there's a force pushing this person forwards. And then there would be friction slowing the skier down. Jackson, who's winning? Who's losing? What's that equal? Doesn't equal acceleration. MA, that's important. And then I think I'm going to do that. Okay. By the way, I would also have no problem then, Jackson, giving you the acceleration and asking you to find mu, which is hidden inside here. Okay? Or asking you to find friction and then asking you to find mu, which is hidden inside there. But for now, let's see here. Wow, I didn't give myself much room, Mr. Dueck. Oh, wrong button. I want this one. Give myself a bit more room. We're going to get A equals F applied minus mu times the normal force all over M. Wait a minute, I don't know the normal force. Or do I? Look. I know the force is the same size as the normal force. I can go mu, and I can replace the normal force with mg. Okay. Someone asked me the other day, by the way, they said, Mr. Dueck, doesn't this little m cancel that little m because one's on the top and one's on the bottom? It would only work if there was also a little m in this expression right here. If I had an m in every single expression, then, Ben, you can cancel. But here I can't. A is going to be F applied, 110 newtons. Mu, 0.11. Yeah, that's about right for powdery snow. M, 47. G, 9.8. Divided by 47. Good yawn? 1.26, is that right, folks? Seeing some nods? I would take 1.3 if you went to 2 sig figs, but 1.26. And it's an acceleration, meters per second squared. If you got that, 3 out of 3. Otherwise, I would probably do something like this. I think I would give you 1 whole mark if I saw that line. I would give you a half mark for that, a half mark for that, and then 1 mark for the answer or something like that. Last one. What are the 2 key words, Sam, in number 6? What words should I mentally underline? Darn right. Because right away, I know A is 0. I know that the forces are. I'm looking for a word being okay, balanced. They're asking me to find what force is required to move this. I think they're asking me to find F applied. And so I think this is a job for a free body diagram. I think it's going to be mg down. Is it sinking into the ground like quicksand? Is it falling to like Superman? No, normal force, same size as mg. Courtney, here's what they're asking me to find. There's friction. Sam, why did I draw friction the same size as F applied? Look up, kiddo. Read me. And so that means the forces are, I'm looking for the letter B. So it's got to be same size. So as a shortcut, I could go winner minus, by the way, I could go like this. F applied minus friction equals MA. But what's A, Sam? And so MA would still be 0. And then I could plus the friction over to this side. See it? And I would get that. Or I can just, as a shortcut, recognize they're balanced. They must be equal to each other. So you can get the long way or the short way. And then you can say friction is mu times the normal force. I don't know the normal force. Oh, but look. You can say friction is mu times mg. So the applied force is going to be mu 0.32 m 20 times 9.8. 0.32 times 20 times 9.8. And I get 62.7 newtons. I would take 63 newtons. Is that right, folks? People nodding. 3 out of 3 for that. Otherwise, I would probably go something like 1, 2, 3, 4, 5 lines. I'd probably go a half mark for that, half mark for that. You know what? I'd go 1 mark for that because that's the key idea, except I lost part of my equal sign there. Then I would go half mark, half mark, half mark. Can you give yourself a lovely score out of 15, please? If you need to lawyer with me, now is the time. Lesson 7, where we left off. So, for those of you who were away, we got to example 4. But let me just quickly refresh your memory. What we asked in lesson 7, Evan, was, well, I lost my notes. Let's bring that back for a second. 3, 2, 1. Let's try that again. There we go. We asked, what if there's more than one mass attached by strings? Now, our argument was this. Franz, we said, first of all, we're not going to let you yank on the string so that there's a big jerk on the string. We're going to have smooth acceleration. And we said, because they're attached by strings, we know each mass will be accelerating at the same rate. Different directions. One can be going up, one can be going sideways, but they're going to be accelerating at the same rate. And so because of that, we said our first strategy was to treat them like one big ubermass. We said that we would go winner, we would do a free body diagram, and then we would write an equation along the rope. And it was going to be winner minus loser equals the mass of all of them times A. Then to find, here's the key phrase, listen close, Courtney, to find individual forces, we would look at an individual mass. And now from there, it's going to be easier if we just jump on in. Example 4, I said, first of all, I like example 4, I like example 4, I like example 4, example 4 is the next question. I said we can even handle problems that have friction. So here we have a mass dangling over a cliff. First of all, is there any way, if these are both inanimate objects, is there any way, don't write this down, that this mass can suddenly on its own start crawling to the left, lifting this mass up? Can we agree that that's not possible? So, if this is going to accelerate that way, Now, it's possible that this might be so heavy that it doesn't accelerate at all. We'll find that out if when we solve for A, we get a negative or 0, then we'll know we picked the wrong winner. So it says find A, the acceleration, and then B, we're going to find the tension in the rope. This is a job for a free body diagram. I typically start from left to right, so I'm going to label this 3.2 kilogram mass first. Savannah, what are the forces acting on this mass? Get the obvious one. Is this mass sinking into the table like quicksand? Is it flying to like Superman? So what else must there be, Savannah, my angel? Bigger, smaller, or the same size as mg? Same size. I don't see any of the other vertical stuff on this mass. Is that okay? What else? Is there a rope touching this mass? So what do we call the force from a rope? What you're feeling right now? Tension. There you go. And tension is pulling it to the right. Is there friction in this question? Well, I gave you a coefficient of friction, so it means that this table is a little bit sticky. And so, Savannah, I know there's probably a force of friction here. Now, pause. Can everyone look up? Savannah, I made a sloppy mistake. Is there more than one mass in this question? Is there more than one mass in this question? I'm going to call this M1G and normal force number 1 to go with mass number 1. And normal friction force number 1 to go with mass number 1. Okay. Those are the forces on that mass. What are the forces acting on the 2.8 kilogram mass? Get the obvious one. Is there more than one mass? I'm going to call this one M2G. If there's 3 masses, I'll call the third one M3G. And you can call whichever one you want to, M1 and M2. Rowan, what I will do, just so our work looks the same, is I will always go this way. So the first one reading from right to left, I'll call M1. I'll call the next one M2. I'll call the next one M3, etc., etc., etc. You don't have to, but just so our work looks the same. Is there a rope touching the 2.8 kilogram mass? So tension is pulling this guy up. Is this 2.8 sitting on a surface, or is it dangling in the air? So is there a normal force? No. This is it. If this is going to accelerate, which way is this going to accelerate? Right and down. Right and down. So here's the question. Who's winning? What's the force that's causing this whole thing to accelerate? Which one? There's several. Be more specific, please. Can you read to me? Okay, that's the key. Did you hear Adam? He said M2G. And I got to be fussy because if you say gravity, what, that one? Okay, so here's what I'm going to decide then. If this is the winner, what we're really saying is any force that ends up pointing down when it gets over to this part of the diagram is going to be a winner plus. Any force that ends up pointing up when it gets to this part of the diagram is going to be loser minus. So it's going to look like this. Ready, Savannah? We're going to walk along the rope like that. Who's winning, Savannah? So the first thing I'm going to write is M2G. Then I run into this tension right here. Is this tension a winner plus or a loser minus? Yep. Because we said anything that ends up pointing up over there is going to be loser minus. Now, this tension right here, when I follow it, when it goes around this corner, I'm going to argue it ends up pointing down. You got to use your imagination, but yes. So down is going to be winner plus. Is M1G along the rope? Is M1G along? So I'm not going to be part of my equation. I'm writing equations along the rope. There is one more force in the same direction of the rope. Which one, Savannah? See it there? Now, follow it. When it gets over here, would it end up pointing down or end up pointing up? Which way is this arrow? It ends up pointing up, I think. Is that okay? So friction is going to be a loser minus. Equals. And for those of you that were away last day or 2 days ago when I did this, Courtney and and all of you. Do you notice, Courtney, I have forces from more than one mass on this side? 2 from there, 2 from there. Do I have forces from more than one mass? Then I have to have more than one mass here. It's M1 plus M2 times A. What was the short way that I wrote that last day? I think I just said M all times A. And if you write that, Kenley, I'm fine. But just for the people that were away, what do I mean by M all? We're going to add the masses together. We're really pretending they're stuck together with me. Savannah, put your pencil down. Stretch. Come on, stretch. Why do we get to stretch? Why are we so relaxed doing these questions? Why are these questions so therapeutic? How come? Jackson, how come? What about tension? Are you saying that every time you do these questions, you lose some tension? Oh, boy, I like that. It's like a little spa treatment. Savannah, what are we trying to find in part A? How to get the A by itself? Divide by what? So, there's the A. What's right next to the A? A bracket. What's the bracket doing to the A? Adding, subtracting, multiplying, or dividing. So I'll move the bracket over. Divide the whole bracket. So I'm going to get this. The M2G drops down like a domino. The minus friction force number 1 drops down. It all is going to get divided by M1 plus M2. That equals A. Or, Savannah, if you wanted to, you could have gone A equals and put the A on this side at this stage if you wanted to as well. This is why I said, Blake, don't try and memorize every single equation out there. It's just not worth it. You have to derive it. It's a better way to learn. Now it's plug and chug. Savannah, how big is M2? Look at the picture. Yep, and that's why it's worth labeling, right? So it's going to be 2.8 times 9.8 minus friction is what times what? Mu. Don't write this down. Look up, look up, look up, look up, look up, look up. My brain thinks times the normal force, but I don't know the normal force. Oh, but look, 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 look. I know another force the same size as the normal force. Which force is the same size as the normal force, folks? Which M? Okay, I got to be fussy. So this is going to be M1G all over 3.2 plus 2.8. Now, if you wanted to go to your calculator on this line, you could. Or, Savannah, if you wanted to plug in mu is 0.12, m is 3. In our notes, we'll do one more line. So I'm going to go A equals 2.8 times 9.8 minus 0.12 times 3.2 times 9.8. I want every single one of you to try typing this into your calculator. Every year I have kids that write this and they can't get the right answer. And it's because they were too lazy to practice in class. You okay with how we put all that together, Savannah, my angel? Is this a fraction? Do I need brackets around the top in this particular fraction? Do I need brackets around the bottom in this particular fraction? So type this. Oh, unless you have the fancy schmancy calculators that do the nice 2-level fractions, and great. But most of us don't. So I have to go bracket 2.8 times 9.8 minus 0.12 times 3.2 times 9.8. And again, you'll notice I use brackets to show multiplication, Logan, when I handwrite, but I just use the times sign to show multiplication because I think that's way easier to read. Divided by, open up a bracket, 3.2 plus 2.8. There is a built-in error check. If we cut this rope, if we took a pair of scissors and we cut the rope, what's the fastest that this could possibly accelerate at if it was in free fall? So I know I'm going to get an answer less than 9.8. If I don't, I've made a typo. You get 3.9461333? I'll go 3.95. Meters per second squared. Let me repeat myself. Allow me to repeat myself. I think I'll repeat myself. So, Evan, what we said is if you give us more than one mass, to find the acceleration, I'll do an equation for everything. Free body diagram first. And my equation is going to be along the rope. Evan, what's B want me to find? Why can't I use this equation to find the chord tension? And this was my best, worst joke ever. I'll bring it up again. So the tensions have vanished. We have a deficit of tension. We have a tension deficit disorder. Because there's no... oh, come on. That's gold. Nothing? Okay. So to find... And here, I'm going to be more general. You said they want me to find tension. I'm going to say they want me to find an individual force. I'm going to look at an individual mass. Which one? It'll work for either one. Which one of these masses looks less yucky to use in our free body diagram? I'd use the 2.8. Okay? So, which way is this 2.8 accelerating, up or down? Yeah, it has to. There's no way it can be going up, because that would mean inanimate objects would suddenly start lifting things up cliffs. Okay, so which way is accelerating?
Down.
Which way is the winning direction? Same answer.
Down.
Okay, so now B. We're just going to write an equation for mass 2. Who's winning? Which one? M2G. Who's losing? Minus tension. Stop. I'm only doing for one mass. So what does that equal? M2A, because I'm just doing for one mass. What am I trying to find?
T.
What's right in front of the T that I don't like, folks? Minus swappy dance time. So I'm going to plus this over, and I'm going to minus this over, and I'm going to get the M2G drops down like a domino. There's a minus M2A. And do you mind, Evan? I'm going to put the T equals on this side. But do you notice what's sitting right here? A. That's why I had to walk through this step first. Now, I would have no problem, Riley, on a test, giving you a question like this, not asking you to find the acceleration, just saying find the tension, and expecting you to realize I got to find the acceleration first. Okay, we'll practice this a bunch more, but just fair warning. I've scrolled down. What was M2? 2 point something? 2.8. And then G is 9.8 minus 2.8. I'm going to write 3.95, but Evan, you know I'm using my answer button right there. It's more accurate and less typing. 2.8 times 9.8 minus 2.8 times answer button. And I got a tension of 16.4 newtons. Anybody else? And it is a force, so it is newtons. You would have got the same answer if you used mass 1. Your equation just would have been yuckier. It would have been tension minus friction 1 equals M1A. Friction 1 is mu times the normal, I don't know the normal force. Oh, but look. It would have worked. And you would have plussed friction over to get tension by itself. All doable. Last one, I think. Yeah. We can even handle more than 2 masses. In fact, this will handle 8 or 12 or 50, but I would never give you that many. The most I'll give you is 3. Okay. You'll notice the question is the same as the one we just did, in that it's asking us to find the acceleration and find the tension. You know what it was a good job for? Yeah, free body diagram. I'm going to start with mass 1, the 1 kilogram mass. What are the forces acting on it? Get the obvious one. I'm going to call this M1G. Is there more than one rope in this question? So I'm going to call this tension 1. You could also call it tension L for left and tension R for right. I usually use numbers. Is there a normal force on the 1 kilogram mass? Is it sitting on a surface? So is there a normal force acting on it? No. What are the forces acting on this mass? Get the obvious one. And I'm going to call it M2G. Is M2 sinking into the ground like quicksand? Is it flying through like Superman? So there's going to be a normal force, and I'm going to call it normal force number 2 to go with mass number 2. There's a rope right here pulling this way, so I'm going to have tension 1 pulling to the left, because there is a rope touching it, so there's tension. For that guy, it's also on this. Both of them are feeling the tension. And this comes out of Newton's third, the fact that forces come in pairs. It's if you pull on one end of the rope, you feel it on the other end of the rope. It's just impossible not to pull on one end of the rope and not feel it on the other end of the rope. Does that make sense? Okay. Friction, because there's a coefficient of friction. So I'm going to draw that right in there. Is there another rope touching mass 2? Yeah. There's another force this way, and Riley, that's going to be tension number 2. So it's getting pulled to the right by the right-hand rope, but it's getting slowed down by the left-hand rope. And that's it for mass 2. What are the forces acting on mass 3? Get the obvious one. M3G. What else? Tension what? Tension number 2 to go with rope number 2 and the other. Okay. Normal force? Not sitting on the surface. Okay. Okay. Kenley, how big is mass 1 exactly in kilograms? How big is mass 3 exactly in kilograms? If this is going to accelerate, is mass 3, if it's going to accelerate, going to move up or going to move down? Got to be moving down. There's no way that this, a 1 kilogram mass, can lift up an 8 and pull a 9. But maybe this can pull everything sideways. So, who's winning? Here we go. You ready? You ready? You ready? We're going to walk along the rope. So I'll draw this in, but I'm going to erase it so it doesn't come on my diagram in just a second. M3G, and what we're saying then is anything that ends up pointing down once it gets to the right-hand side is going to be a winner plus. This tension 2 here, Ken Lee, winner or loser? Yep. This tension 2, winner? Yeah, when you follow it, it ends up pointing down and right. Then I have this tension 1. Follow it, follow it. I think it ends up pointing up, loser, when it gets to this side. I also have friction force, and I should have called this friction force number 1 to go with mass number 1, just to keep my numbers in sync. Friction force number 1, winner or loser? Yeah. And then this tension 1, you might be tempted to say, Mr. Dueck, it's pointing up, it's a loser. But when you follow it, follow it, follow it, follow it, follow it, I think when it gets to this side, it ends up pointing down, winner plus. And this M1G, you might be tempted to say, Dueck, it's down, it's a winner plus. But if you follow it, follow it, follow it, follow it, follow it, follow it, follow it over to here, I think when it gets to this side, it ends up pointing loser minus. Have we got all the forces along the rope? Mr. Dueck, don't we need to include those? Are they along the rope? What's that going to equal? M all times A. And by M all, I mean mass 1 plus mass 2 plus mass 3, because I have forces from mass 1 and mass 2 and mass 3 in this diagram. Oh, this is like a double spa treatment. Do you know why? I'm losing twice as much tension. Oh, good stretch. I like this. Gone, gone, gone. Mr. Dueck, what, Sam? Do I have to write the tension if I know they're going to cancel? I won't take marks off if you don't. I always do, and this is dumb, but I always do, because when I do cross out the tensions, it does make my little math nerd heart do a bit of a relaxing giggle, and I figure that relaxes me on a test or a quiz, which is lame, but it works for me. So, Kenley, what am I trying to find in part A? How to get the A by itself. Yeah, which was the bracket that Savannah had earlier as well. Whichever way you want to think about it. So I think, Kenley, you're telling me that A equals, on the bottom, we're going to have M1 plus M2 plus M3 M all. And we're going to have M3G minus, pause, friction force number 1. Sorry, you know what? I should have called that friction force number 2 to go with mass number 2. That was really sloppy of me, wasn't it? Yes? Yeah. Friction is what times what? So it's going to be mu times the what? I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Ah. And then there's also a minus M1G. You know what? I didn't need to make this line that long. There you go. Now again, if you really want to, Logan, you can try memorizing all these equations. Don't. Learn to derive them. We're now at the plug and chug stage. Kenley, M3. G, 9.8 minus 0.25, 9.8 minus 1 times 9.8 all over 1 plus 9 plus 8. I would strongly encourage all of you to try typing that in to see if you can get the correct answer. And if you're not getting the correct answer, snag me at the end of the lesson and I'll walk through how to do this on your calculator. For me, I have to put a big uber bracket around the top. 8 times 9.8 minus 0.25 times 9 times 9.8 minus 1 times 9.8, close bracket, divided by, open bracket, 1 plus 9 plus 8. There is a built-in error check. The fastest that this 8 kilogram mass could be accelerating is 9.8. Ah! Do you get 2.58611111111? 2.59 if I go to 3 sig figs? Or am I wrong? I see a nod. I see a head shake. Am I wrong? I'm right? Oh, okay. 2.59. Cool. Carlos, what's B want me to find?
The tension of both fluids.
Okay, I'm going to go like this. On the left, I'm going to do tension 1. On the right, I'm going to do tension 2. Which mass don't I want to use? Which one has got, it looks the ugliest to work with? Yeah, this middle one here. It's all sorts of junk on it. I'm going to do an equation for this to find tension 1. I'm going to do an equation for this to find tension 3. Sorry, tension 2. Which way is mass 1 accelerating? Give me my equation. You see it?
Oh yeah, T1
Yep.
minus M1G
Equals
M1A.
M1A. Which A? My answer from part B. How would I get the T by itself, T1 by itself?
You will add the M1G to it.
So it's T1 is going to be M1A plus M1G. Pause there. Let's go to the second mass here. Let's go to the second mass here. Excuse me. Jagger, which way is mass 3 accelerating, up or down?
Down.
Can you give me my equation for mass 3? Who's winning? Who's losing? Which one? Tension number what? Yeah, it's important. What's that going to equal? Which M?
3.
because we're only looking at mass 3, so it's only going to be mass 3. Here, it was M all, because we had forces from all. Okay. How would you get the T by itself here? Swappy dance. So we're going to get tension 2 equals M3G minus M3A. Hey, this half of the class, if you haven't started, you can find tension 2 using your answer button for acceleration. This half of the class, you can find tension 1 using your answer button for acceleration. The only reason I'm saying that is once I've used my answer button once, I can't reuse it, and so I'm going to have some rounding error. I should have written down 5 or 6 sig figs here. I should have written down 2.5861 somewhere off in the margin, knowing I was going to be using it more than once. M1 was 1, right? 1 times answer button plus 1 times 9.8. For tension 1, do you get 12.4? Or am I wrong? It was 1, wasn't it? Yeah. No? Good. Yes? And those of you that do tension 2, I'm going to cheat, and I'll get my acceleration back in my answer button memory. Tension 2 is going to be 8 times 9.8 minus 8 times answer button. I think tension 2 is going to be 57.7 newtons. I hope that's right. I'm also doing that because I got people yawning like crazy. Yeah?
Why is it tension 1 that's having plus
So it starts with this equation here. Since this is accelerating up, tension 1 is the winner. Okay? So that's where this equation came from. How would I get the tension 1 by itself? What's right in front of the M1G here? So I plus it over. That's where that came from. Which way is this one accelerating? So that's the winner. So I get, you'll notice here, tension was in front and mg was behind. Here, mg is in front minus tension is behind, and I did the swappy dance. I plus that there, and I minus that there. Okay? Yeah? That's a lot to throw at you. And I'm going to give you a lot of homework. Your homework is going to be number 1, number 2, 3 is good, 4 is good, 5 is good, 6 is good, 7 is good. 7 is tricky. 7B is really tricky. Impress me to see if you can get it. Someone already has, and they impressed me. They know who they are. 8 is good. 9 is good. 10 is good. There is no number 11. 12 you can try. 12 is from a Physics 12 scholarship exam. But if you think about it the right way, Savannah, you can do this all with Physics 11, but you can put a star next to it. When I put a star next to it, that's my way of saying that's not fair game for a test. That's way harder than I would ask on a test. But if you're looking for a good challenge, okay?